Okay, so let's talk about integration by parts. Most likely you've learned how to integrate using probably just U-Sub actually, but there are way more ways you can integrate stuff. Some are incredibly annoying, and integration by parts just happens to be one of them. So the equation that you're going to have to memorize for integration by parts is that um, remember you want to integrate this. Your integration, or so integral of u dv is going to be uv minus integral of v du. And this looks pretty confusing as fuck, but it's not too bad. So a quick example would be, now if you're wondering why does this work, I have no clue. I don't know why it works. I just know the equation works. Integral of, let's say, x cosine x dx. Now, if you're just starting integration by parts, you might be thinking, oh, I might try U-Sub. Well, what the hell is your u going to be? X? That means you have du is dx, but we have cosine x to worry about, so that's not going to work. If u is cosine x, that means your du is negative sine x dx. Well, we don't have negative sine here. That's not going to work. Yeah, that's it. I'm out of options. So this is where you have to do integration by parts. Now you have to pick from here a u and a dv, and you have to pick everything. You can't leave one. You can't leave something out. And what I mean by that is that if I pick a u, let's say x, my u is x. I pick that as x, or u, sorry, if I pick that as u, then the rest of it has to be dv, all of it. You can't leave anything out. So dv is going to be cosine x dx. Now, the first few days that you do this, you're not going to know what your u and dv is going to be. You're just going to have to guess and hope that it works. If it looks like your work's going nowhere, then it probably is going nowhere, honestly. And that's where you have to start all over. Sometimes you might have to do 4 of these and then you'll see that you get the correct answer. But this is an easier example. Anyways, so once you pick your u and dv, you have to integrate the u and not integrate. You have to take the derivative of u and integrate the dv. So du is x, therefore u is x, therefore du is dx. Now integral or integrate both sides. So integral of dv is v, integral of cosine x is sine x. Okay. Great. Now what? Well, we plug it in up here. So integral of your u dv is this thing. Okay. So integral of x cosine x dx equals u times v, which turns out to be x times sine x, minus integral of v du. V is sine x, and du is dx. And then you got just one more easy step to do here. So x sine x, what's the integral of sine x? Negative cosine x plus c. Don't forget the c. And negative negative, you simplify. I think that's the word. So negative negative makes it positive. Cosine x plus c. So that's your integral for this thing. This is probably the easiest example I can give you. There are some trickier things I can say. So move on to the next part, number 2. what is the integral of x squared e to the x dx? Now, here's a trick you can do. Which one, so x squared or e to the x, if I take the derivative multiple times, which one will go to 0? That is usually going to be my u. This will always be e to the x. No matter how many times you take the derivative, it'll always stay as e to the x. Whereas this will go towards 2x, 2, and then finally 0. That goes to 0 if you take the derivative 1, 2, 3 times. So most likely, this is my u. So let's test it out. My u is x squared. My dv is e to the x dx. So what does that make my du? It's 2x dx. And my v as e to the x. Now remember, we have to plug it into that uv minus integral of v du. Well, let's do that now. So integral of x squared e to the x dx is equal to uv, which is x squared and e to the x, fine, minus integral of v, which is e to the x, du. Du is 2x dx. Okay, now how are you going to integrate this? It wasn't like the previous problem where we integrate a sine and just get negative cosine. This is odd looking. And if something looks odd, it's most likely going to be integration by parts. So you're going to have to do this again. So that's the tricky part about integration by parts. We're going to have to do this again. Now we pick our new u and a new dv. So between those two, which one will go towards 0 if you take the derivative multiple times? 2x. So that's probably going to be my u. That means the rest of it that I didn't pick, the e to the x and dx, is going to be my dv. Like that. So my du is 2 dx. My v is e to the x. And I do it again. It looks annoying, but yeah, I have nothing good to say about that. It is annoying. Minus, now, because I'm subtracting a completely new integral by parts, I'm going to just put this in giant parentheses. Now, minus, this is, again, uv minus v du, uv. So there's my uv minus integral of v du. V is e to the x, du is 2 dx. Thankfully, we could integrate this one. So when I simplify, I get x squared e to the x minus 2x e to the x minus minus makes a plus integral of 2e to the x dx. Therefore, my final answer is x squared e to the x minus 2x e to the x plus 2e to the x plus c. Not bad, I think. But this problem will get much worse, much worse. I'll talk about that in the next video.